Right, so welcome again to the Senior Design Conference here at the RAM Wheelchair Accessible Mower Team. Project sponsor is Lee Friesen. I'm Adam Parsing.
Spencer Lutz.
I'm Hunter Matt.
And I'm Jacob Min. Just a quick project overview. Our sponsor, his father is wheelchair bound. He wants to be able to mow his own lawn. Still, there's also the potential for this product to be marketable in the future and increase job opportunities. So we'll be creating a fully functional wheelchair accessible lawnmower that can be operated from a wheelchair. The mower will be modified with the JC Country Clipper. And our motivation for this project stems from the fact that lawn care is not currently accessible to people in wheelchair, and there are about 65 million people worldwide that are wheelchair bound. We also want to improve on last year's design, as this is a second iteration of the project, and we'll show last year's project on the next slide.
Right, so as Jay mentioned, this is a second year project. This was the final product of last year's design. The way they achieved their goal was by using lead screws and linear actuators. They used 2 lead screws to control the horizontal movement, and then once it was fully extended, they used 4 linear actuators to drop the platform down and raise it up once the person was on there. What we want to do is make this a little more rigid, because when you grab those actuators and shake it, the platform kind of wobbled, and having a person on there cannot be as safe. Our project sponsor also wanted to look a little more OEM than this to make it look a little better. This is our project statement. The Wheelchair Accessible Mower Team bridges the gap between accessibility and lawn care by creating a fully functional lawnmower that can be operated from a wheelchair.
Some goals with this project: a fully functioning lawnmower for a person on a wheelchair, ingress egress lift system, safely get a person in a wheelchair on the mower, implement safety devices for that ingress egress lift, and then comfortable mower controls for that person.
Some completed similar work. This is the runnability UVL or under vehicle lift. It is a compact under vehicle lift that allows for minimum storage space and it can also lift up to 750 pounds. Some of the pros of this is that it's proven in industry that this is a very successful product of runnabilities and is also capable of lifting large loads, which is a similar task that we are hoping to achieve.
So some concepts that we looked into the first semester. Our project sponsor really wanted a ramp. We dug into the ramp pretty heavily. We needed a 3-section telescopic ramp. There's nothing on it. There's nothing on the market like it at all. There's 2-section telescopic ramps, not 3. With size constraints for a mower, wasn't going to work. So we looked at a scissor lift idea. When we ran calcs for the torque needed to raise and lower the load, it was extreme, and you can't get linear actuators to develop that. So we went to a 4-bar linkage lift system, which we'll dive into here deeper.
So when determining if we wanted to do a ramp or a lift, we had a few categories to help judge our decision, that being lawnmower accessibility, deployment size, ease of design, the retrofitability capabilities, the ability to have an emergency backup system, the aesthetics or looks, and the durability of the lift or ramp itself. After some consideration, we determined that the lift would be the way to go. The deployment size was pretty considerable for us. The lift was going to be about 45 inches of space out there. The motor was ramped within over 12 feet. And if you think about it, that's just extra space that has to be cleared out in front of that mower when you're wanting to get on or get off of that mower. The other thing was the accessibility of the mower with the ramp. The ramp angle that would have had to be to achieve more length would have been, the ramp would have just been too long and too steep for somebody to have to back up it to get on or get on the mower, and that's why we chose the lift.
So here's our current design model. One thing to note that is missing is the control panel that'll go about right here. We just haven't modeled that in. There's some factors that we haven't quite figured out. That'll be added. So here's a simulation of how this whole system will work. The lift is set out. It'll raise about 2 inches from its neutral axis. The person on the wheelchair will wheel onto that with the use of a transfer plate. The lift will drop. A roll stop will be activated to allow them to get off the lift, and then it will lift back up and to set away. So here's kind of our 3 main phases of the lift: stowed, raised, and lowered. As you can see in the stowed version, it's nice and compact. In the raised version, it has the transfer plate, it's level with the rigid platform. Easy access onto the rigid platform from the lift. And then in the lower version, it's on the ground, ready to be activated.
This is our mower frame. Something to point out, just about the only thing that's not being modified on the frame itself is the engine mount. Some of the key changes is that we'll be dropping the frame in front of the driving wheels by 3 inches, and that's just for space optimization because we will be redesigning the linkages for the cutting deck, which will give us some extra space to be able to drop it. And then we'll also be extending the frame by about 20 inches. That's just to give us room to fit all of our cassette framing, as well as we'll be widening the frame as well.
So here's a skeleton of the cassette frame. It's a spider leg design, so to speak. So the spider legs will go down to the mower frame that we just talked about. We'll use a rack and pinion gear system to move that cassette in and out. The rack will be welded or connected to this frame design. And then the cassette will run in that C channel down in the bottom right-hand corner. We'll use bearings to eliminate friction and create a nice smooth movement.
So that exploded photo that you see on the left, that is the driving motor for our pinion gear. That's going to be the driving force, as Spencer said. Also, you can see these wheels here. Those are going to be bearings that will be running in that C channel that Spencer talked about. Additional features will be 2 2,000-pound linear actuators. Those are the black things there. That'll be driving force behind raising and lowering our lift. It'll consist of an 8-inch stroke. That will give us plenty of movement to raise and lower it, as well as we have a 2-inch stroke linear actuator on the bottom to power our roll stop. So it'll be flipped up when that lift is not on the ground, and it will be flattened out when the person wanting to get on or off of the lift.
All right, so a little bit about the mower that we were modifying. When we first got it and dug into it, it was a fixed 4-bar linkage style control movement. And this posed to be an issue in our design because we had to design around it to prove to be too much of an issue. So we were switching over to a push-pull table style. They've been used in older mowers, and one of our design review committee members had one of these style mowers, so we went out and took a look at it, and it connects to the movement joystick the same way as the 4-bar linkage. So it'll allow us to be able to route the cables in any way that is necessary to design around. As Spencer mentioned, the control panel will go up from our frame to about where the armrest is located. And on there will feature the movement joystick, the cutting deck, start, stop, mower, key, your throttle, your choke, and we're also going to add one of your actuator for cutting deck height adjustment. So a little bit about this validation for our design. The first step that we took was weighing the mower. We did this the same way that the DOT weighs trucks. They put a scale under each wheel, and then at the end they added all of the weight to determine how heavy your load is. So we just used some bathroom scales to put under each wheel. Ended up being a total of 777 pounds, which validated the spec sheet that we found online at 775. This allowed for some center of gravity and moment calculations.
So this is a snapshot of our mower when it is at its worst tipping condition. As Adam said, we wanted to calculate what our maximum load, so the person in the wheelchair will be before the mower wants to tip forward. Something to note here is just the location for center of gravity that we were able to calculate. That's that blue X there. And we'll talk about some assumptions. We were operating on the assumptions that the mower's weight can be summarized as a point load at the center of gravity, and then that the load, so again, the person in the wheelchair can be summarized at a point in the middle of the platform. And then we're operating with a design load goal of 600 pounds. This is anonymous to, as we've seen online, if a forklift picks up too large of a load, it will fall forward in a dramatic style. Same thing that we're trying to not happen, have happen, but in case our load is going to be a person, so we really want to make sure it's not going to happen. So we're able to calculate our maximum load of the person in the wheelchair. That is going to be 1,141 pounds about. And then with our design load pool of 600 pounds, we're able to calculate a factor of safety of 1.9.
Right, so that's how I mentioned when it is perfectly horizontal, that'll be our worst case. That'll also be the worst case when scenario for the lifting members itself. So what we did is we threw our lifting arms into SolidWorks and ran some stress simulations. And as can be seen, there's not a lot of stress to be shown on our members as they're half-inch steel. The stress that can be noted in the front lift arm, which is where the actuator is actually pushing, is right where the gusset meets, and there's corners we plan on reducing this by adding a fillet to it, just rounding them out. The back arm, the stress that can be seen in this bottom corner is only because we had to fix it in a horizontal plane. When we're actually pushing on it, it'll be able to rotate, but if we didn't fix it in SolidWorks, it would have just spun, the design wouldn't have actually ran. But as can be seen, there's not a lot of areas where we have any stress. And the chart on the right shows where it would go.
This is our Gantt chart. It just shows deadlines that we've had to meet this semester and future ones that we have next semester. Some big ones from this semester include our preliminary design review and our initial testing. So we had to complete next semester. We'll just have to have some demos of our finished product and then get that to your test. This is our budget. You can see it in the form of a table, and there's a pie chart. Our total cost right now is about $2,941. We split our costs into a few different categories. Metal right now is the category we're spending the most in, just because we have many parts we need to manufacture. And the second most is motors, we have actuators that we supply.
Right, so this is our mower. We got it about a month and a half ago, and these are just some pictures that we've been slowly taking apart. So the first step was removing the seat and some of the side paneling, which revealed it to this, where the gas tank was under that front panel. We worked together as a team to get that gas tank out because it was full, so we had to dump it into a garbage can and then pull it off. I did all over my garage for it. But so after that, we dug into the 4-bar linkage, which can kind of be seen. There's like a bronze rod that goes through there. Ended up cutting that and then removing it, which brought us down to here. And then the next thing that we had to do was remove the cutting deck, and we did that here last week. Hunter's got it. So now it's pretty much just a bare skeleton, and we plan on removing these C-channels and then custom fabbing a frame that was shown back when Hunter talked about it. The only thing that will be the same is the mounting plate for the motor, and then we have to determine a new way to electrically move the cutting deck. Right? These are references.
How do you keep the wheelchair like secure?
Right, so our plan for that is last year's team had it's almost like a fifth wheel plate. So you slide into it and it locks you in place. They have a lever for release. We plan on either redesigning theirs or maybe just swapping it over, depending on how much time we have. And then as far as to keep the wheelchair from moving like this, plan on having like almost a ratchet strap style system like on the new boats. You just press a button, sinks you down. If you connect that towards the front of the wheelchair, it'll keep you from moving side to side.
Have done any calculation for like actual use or I don't know, degree, or are you just assuming flat?
As far as like tipping,
Yeah, because you mentioned like center of gravity, but I don't know how far you can go before it's like unsafe.
yeah. We haven't done any calculations as far as tipping, but with how low it is to the ground, how wide it is, I find it hard to imagine that it would ever tip. And we do plan on installing a rollover protection bar at the end.
How long? Remind me how long it takes for operation to get someone from the ground on top of the mower.
Yeah, so I want to say cassetting the cassette straight out will take a little over 20 seconds. And then I don't have an exact time, but the inner actuators at full load operate with, I want to say it's like 0.3 inches per second. So it'll probably be another 40 seconds to lower it all the way to the ground. And then probably 5 or so seconds to raise up those 2 inches.
And then follow-up question, do you think on that platform you'll add any like safety mechanisms when you're lifting the person up onto it just to ensure, or do you think it'll be slow enough where you won't be seeing that?
Yeah, so twofold. One, they should have their wheelchair lock. That'll be in the instruction manual that will create to lock the wheelchair so it doesn't move. We also have 3-inch rails on the sides, and then that roll stop is also 3 inches tall. In addition, as that ramp or as the lift is lowering, those lift arms will come up and kind of box in a little bit. but like I said, we have those precautions for safety.
Considered like the electric wheelchairs, the ones that the wheels are kind of different and the whole wheelchair overall is heavier.
Yep, so they, as far as the footprint goes, they don't take up a significant amount for as they're not significantly different in shape as the footprint of the wheelchairs that we were showing here. And weight wise, you know, we're thinking maybe about a 200-pound person, and then those the powered chairs they're about 350 pounds. And then with our factor of safety, we should cover most powered chairs, but we will have, you know, say weight limits on there as well. So if somebody has just a monstrous lift or a monstrous power chair, you know, they might exceed it. But for most power chairs, we have that covered as far as lift weight changes goes.
As far as you're holding the wheelchair still, are you accounting for both styles? Like to work?
Yeah, so the docking mechanism that Adam was talking about, that is actually used in a lot of car applications. And they can be modified on both power chairs and like mechanical rolling chairs. And so it'll cover the basis for both of them.
Probably be like two different tech deals, or one for like a manual and then one for an electric, just because they're different, so you can't have the exact same, but it's just a simple swap.
Do you have an estimated weight of what you'll actually be adding to the mower? What should it weigh when you're done?
Yeah, so this is our breakdown of our weight that we have that we'll be adding as far as metal and actuators and stuff like that. We'll be adding about 360 pounds. So we'll be looking at a little over 1,000 pounds as total weight. And then you would add 600 pounds for the lift and wheelchair. So in total, we'll be right on 1,600 pounds. And then so that we have this is a breakdown of what our added mass is going to be. Most of it's going to be in that cassette frame just because it is going to be large steel.
When after you're like park it and get off, are you gonna planning on leaving the cassette down or pulling it back up and into the
That's going to be preference on the user, right? There'll be attendants that'll control operations. So if they want to, when they're out of the lift, they're able to stow it on the pendant and then, you know, set the pendant on its docking area. Change it.
I think Doug was trying to get a question.
Yeah, you're lowering the frame by 3 inches, but your front axle will not be lower than 3 inches, right? So
Yeah.
just to get space for the actuators and whatnot?
That's just to give us, just to like help us with the lengths of those lift arms, because the longer they are, the more work that's going to be on those lift arms. So we're lowering it just to help us out, to give us as much break as we can with those stresses on those lift arms. And we aren't planning on lowering just because the wheels are 10 inches in diameter, and that bottom that cassette is going to be right about 10 inches. So we're going to kind of raise it up, and there's applications in lawnmowers where they do similar things. So it's something we're going to be designing as well.
But it will affect your overall deck height, though, right? You won't be able to mow quite as high as you could previously, or?
I think we're about the same.
They're calculated from about 1 inch to 6 inches high, which is pretty high for a lawnmower, really.
There was about a 5-inch gap between the top of the deck and the bottom of the frame where it was fully raised up. So take a little bit of the width on all of it.
One last question. Okay, really nice job, guys. Electrically, will it be a larger battery or?
Yeah, we do plan on increasing the battery quite substantially.
Yeah, we're gonna oversize that battery. We wanna add an alternator in as well, when the motor's running, just to keep that charged. And then we'll add a trickle charger system when it's stored in the garage that just always be maintained. So we'll add those 3 aspects.
One more question. Will the deck be moved? You're gonna lengthen the frame, right? Will the deck be moved further up front to help, you know,
No.
trim around edges or?
So if we were to move the deck, we would have to make a custom belt application for that. So by not moving the deck at all, we can still use the belts.
Okay, so I think to stay on schedule, we'll probably have to have the rest of the questions out in the hallway. So let's thank our presenters.